Hi everyone. I'm so excited to be here again with you. And well, virtually, I wish I can talk to you directly. It's just so weird to see everyone on the screen instead of seeing everyone on stage and interact with you guys. But hey, what can we do? We need to be safe until all of us are vaccinated, right? So anyway, let's enjoy our time together virtually as much as we can with XDay and UI component in view. So before we start, I'm Maya Shavin, and you can follow me at my Maya Shavin on Twitter or GitHub, or you can also visit my mayashavin.com website to for a little bit of talk, post, blog post, anything you find interesting about front end development. I love to blog about them and share my knowledge. Okay, so let's talk about our topic today. View tree composition with API in view tree is actually a very good improvement, right? It allows us to it's given an additional method or additional approach to actually control and view our component better and make it more reusable, more scalable, and also it allows us now to write a proper functional component with a more in control local state in a much more straightforward direction. For example, let's say we have a component that all it does is to load an image on demand. When user click a button, it will load an image and displays the image. This is how we're going to write it using composition API and in view tree. So we have a setup function, and what it does is it set the local state, which is kitty using ref, and then it have a function called get kitty, which is it's bind to the on click event of the button, and what it does is actually update the local state after it fetch the image and update the image URL and then render component, which and then it render the component with the new value of the image, or it only render the button depending on whether the image is updated or not. Very simple, right? And the result is click, image load, that's it. Now, what if user click on the image and the image took time to load and they was very impatient and they do a lot of click? We want it to be to prevent user to click a lot of click, because every click like that you send a request to the server and it will soon make our application become very costly. And so we want to disable the button while the image is loading or even after the image is loading. Or we want to provide the user some sort of loading message or custom loading message to tell the user, hey, the image is loading, please wait. Or we also want to add some error state in case the image is failed to load. Well, we never know what happened to the server, right? So all of this we need to handle. And what to do if we want more use case? Well, by that time, our little component will turn into a much bigger component in which we have a loading state, we have an arrow local data local state, we have a handle for fetch event when it's going to the arrow, and we also have some bunch of if and else condition before we render in order to render the proper element or proper UI according to this state. Let's say if the image, the kitty have a value, then we render the image. If the arrow have a value, we render the arrow. If the loading have a value, then we render the loading, so that we render the correct things to the user. And the more use case we want to put in, we add the component. We have more code to the component, and this is where the component get more and more problematic to maintain. But unfortunately, this is a very common and direct approach that most of us developers always take. Because when we get a new component, we get a new feature or new component requirements or to develop, we tend to define a basic actions. Like we tend to start from the very basic. Let's say we have a low or not low, we always start with, okay, let's say a boolean, low or not low. and very simple logic. And then from then, if later on we receive the requirements to handle a new feature or new bug fix, then we start to add another layer on top of the basic logic that we just created. And then we found another, let's say, features. Let's say we want to display an arrow, custom arrow depend on the arrow number. Then we add another layer on top. Also, bug fix this bug. We also add another layer on top of the existing component we would just created from the previous layer, and more and more, and this onto the top. And this is called the bottom-up approach. Eventually, the problem with the bottom-up approach is that you start from very tiny things and then you start growing until it's become a huge component logic that you can no longer manage and read. And that's why it's very hard to maintain. It's very hard to test, because one is you end up with large thing. It's very hard for us, for developers to understand which part need to be tested and how to test it correctly, and how to make sure that the backward compatibility is maintained. And huge code base also means that it's very hard to understand, and because of hard to understand, it's very easy to make bugs that you don't even realize. At the end, at some point, the user will end up be the one who suffer whatever we create, right? And that is when we talk about finite state machines. Well, finite state machines is, in the other word, we call it deterministic finite automata. Oh, I know. Just like the name, the definition is super hard to understand. It's not easy. It's not hard. It's super hard. Whether or not you study computer science or not, because who understand a fight tube? Come on. And so just forget on this theoretical definition. I would like to define it a little bit shorter and simpler. Deterministic finite automaton means that is we have a whole sequence is represented by a sequence of states where you have one initial state, and we have a finite number of states and events where we can create a transition mapped from the event by connecting the event to the state, by execution related events to like moving from one state to other. An example of deterministic finite automation can be shown with fetch. The fetch API. Let's say we have initial state at idle, and then when we trigger the event fetch, then we move from idle to loading, and then one is result, which is find the event result. It go to reset success, or if I reject event, it go to failure. And on failure, you can actually send out the event to retry, depending on how you do it. So that's how the fetch that's how the fetch is done in theory. And also that is we call state machines. Well, so at this point you probably may wonder, what is the relation between state machines and what is so theoretical with UI development? Because what we just saw an example right now is just fetch, which means you communicate with the server, and that is common. What does that have to do with UI? Oh well, this is not new, right? You're probably familiar to this. When we talk about UI development, we always talk about wireframes of the application, create user flow, user story, in which each of the user behavior would lead to a specific state or a specific view or a specific component response. That means all the UI phase and components are very dependent. They are not independent from each other. They actually connect very tightly to each other and actually communicate with each other. And the transition between one view or one component to the other or one page to another is really based on action, which in fact are events which was executed or triggered by the user through certain action, through certain event like on click, like on chain, and so on. And that's why building user interfaces or building user flows, or you can just say building user diagrams, or you can say building user trees. Whenever name you use, it actually you're building user graphs, or you can say you're building state graphs. And state graphs are handling by state machines, can be handling by state machine. Also, state machine is actually used everywhere. Why? Well, remember this: promises, as in away, callbacks, observable, all of these are actually, in fact, some sort of state machines. But not all of these are not really meant for UI. It's more for communicate or maybe observable for detecting user UI changes. But anyway, this is some sort of state machine were created for you. So in for UI, we have XDay. This is our main topic. Yeah, right. So XDay is an open source JavaScript and TypeScript supported library package which aim to provide state machines and state charts for modern web. Well, I didn't create this definition. I just copied it from directly from their documentation page. So yeah, and it's already supported React, Vue, and Svelte. Awesome, right? They have a very great documentation page with a very clear and very clean tutorial recipe to start with, the guideline and how to and explain very carefully the concept of state machines and states and how to handle in that. In addition, so what it actually does, it provides a whole set of API that allow you to create, interpret, which to allow to control the machines and execute a state machines based on the configuration you provide. And also in addition, it allows you to manage the state machines together with or without being nested within each other. Some of the main API of XDay can be listed here on machine, which is the main class for creating a machine instance. A transition is to move from one state to another. Events are events. Well, simple. Actions are like a fire and forget side effect. So if you want to do some extra side effect when you transit from one state in another, we use an actions, and states are state. So let's go back to our fetch example. So in our fetch example, we have the diagram. So how do we write it in XDay? Well, we call the machines, we pass the configuration inside, and to create a machine instance that handling fetch, which initial state is IO, and then we define the set of states like IO would have an event called fetch. One is what trigger fetch, trigger on idle state, it will move to loading, and then we have loading, which if it was result event was triggered on loading state, it will move to success, or it was reject. If the reject event was triggered, it will move to failure, and so on, success and failure. Simple as that. That's all. Now we have a state machine with 4 different states in just a very organizing structure. So far, so good? Cool. Now the next question. We're talking about handling in JavaScript. So how do we do that in Vue? Well, we can use normal JavaScript package that provided by XDay, or we can use an additional XDay/Vue, which is the package that dedicated for Vue user, compatible with Vue 3. And actually, it aligned to composition API so that it can make your experience working with XState and Vue much better. Let's take an example to understand more. We're talking about toggle component. What it does is that it moves from on and up, on and up. Simple, right? Only two states. Inactive, which when you click on it, it will which is you trigger the toggle. We trigger the toggle event, it will move to active. And when you trigger toggle event of the active state, it will move back to inactive. That's it. So to write it in XState, we will first import machine from XState package, and then we create an instance by passing the object of configuration, which we have initial state at inactive, and then we define a bunch of state. We call it inactive or on toggle, then we move to active, inactive, on toggle, move to inactive. Straightforward. And next, how we put it in the Vue component. Oh, well, I know. You're pretty bored by now, right? So seeing code listed on here, you don't really see, okay, how do I know that it's working? I know what you're thinking. So let's see how we're going to do it in real coding. So, shall we? I hope I will not mess it. So I have a component, which is toggle. And it's actually written very simple. We have a span, and it have a background, and have an indicator, we have a background style, it computed, and it also written with the composition API, of course. So we have a setup, it receive forms, the initial state, and they have a toggle, which is actually do just toggle from one value to another. And then we have a background state, and that's it. Simple, right? So how do we do this with state machine? So first I took the code we just saw. I put in the file called toggle, is from the machine state, and then I'm going to here, and what it does is I need to import from XState in order for us to use and control the machine. We actually need to import a specific method from XState in order to use it. So here, let's first import the machine itself. So here, and we import the interpret, which the function that take the machine and give you back the control of the machine, that start the machine and make it into a real service, a toggle service, a machine service. So here we put the machine. Okay, and now we can use this, or what we do is, sorry, we don't need this. So we need to create the service. So we can create a service equal interpret toggle, right? And then what we do here, we take the initial state of the service at our initial local data state, and the toggle, the service provides a method called send. This method is transition between it will send, it will trigger the event that we pass into. So we pass into the toggle event, and now we need to start the service, which is start. But before we start, we need to make sure that one is sent, one is during the transition. We need to update the value of the local state of the component. So what we do is we do service, and on transition, this is the side effect, and we do new state. Transition receive a function with a new state, and then we have the state equal value for new state. Okay, now what we do here is we cannot use this thing anymore because the initial state is not a boolean. It actually is print the inactive or active. So what we need to do, XState actually provides us a bunch of method called matches, which return to true or false if the state is actually the state we're looking for. Let's say we're looking for an active state, and here we're looking for also the active state, and that's it. Let's take a look. So now it works, right? And in order to us to understand about the state, we can console log the state, console log the new state. And now we can see the state is here. You can see the first thing going in, we have the state, we have the event, the state, and we can also see that have a bunch of other properties to tell us more information about this state. And then when we click, we get the property, and we get the event called toggle name and external, and so on. Cool. Now we kept the component works, but let's say we still have a computed things. Can we somehow make the computed disappear or be part of the machine, because we don't want to? It most likely will not change, especially the background color. So we can actually use what you call a context. In the machine, it has a context field which contain the data of the machine itself, some additional data. So let's say we can have a background. So we can have a background, and that's it. Background color, the initial state is the inactive one. And now we also need to add some side effect when we transition from one state to another. We need to update the background, and we need to update the indicator with the new CSS styling. So we do here, we use an actions, we provide a side effect. Action will receive, we use assign from X state to present a partial context to update. So assign receive an object for context, and here we already have and all you need to do is this background, we need to select image, and we just copy the whole thing. We copy the background from here, and then we copy the indicator. And then we have the transform also inside. Let's do the same thing for inactive. So inactive, we already have the initial state, so we don't need to change it. So for active, we take it from here, and then we move it to RAM. And now we have the side effect defined for each state. And what we're doing here, we just need to remove the compute. And also we have here, we'll take the state, we get the context, and we get the background, right? And we have state, context, indicator, right? And now let's check if our working, and it works. And if we take a look on the state, we can see the context it changed, and that's another thing. Now the next question is, what if I want to take this logic away from the component and share share the same machine with other component aside the toggle component? Well, for that we're going to use XView XState view package. So we create a service, a service file called toggle service, and we use a use service of the XState view, and then we create we export a method called use toggle machine, which return the use service, create an instance of the service itself when we start the toggle service. And now in the toggle, we don't really need to interpret anymore, and we can change this one to service, and then we get the toggle service, and we call use toggle machine, and here we don't need this interpret. So what we does is we get the state and we get the send method from, because the use toggle machine actually returned to us a service already. So we just call it, and the service already have the state and have this send method. So we also don't need this part, and the toggle it will just call the send method. So, and we don't need the transition, and we don't need the start, and we also don't need the rep anymore because it's already built in the composition API from the package. And here you go, it works, right? Cool. And that's it. Now we can asset but now what if we want to asset the machine from other components in app? Then we can actually go here and we call the setup, and we can also get the machine from the service itself. We get the state, and then we print it out. And as you can see here, we can see that it print out the mode, and we present it change. And the two components doesn't really need to depend on each other. Okay, cool. So that's, I hope it's not blah 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 anymore. So we have so far so good. Yeah, I hope. Anyway, so as you can see, XState is very cool and have a lot of advantage that I love to share with you. First, it's very clear visual view. You can actually see the code flow, the state flow visually by using in XState visualizer. They provide us the visualizer, which you can actually put the code. Will I take the whole code from here, and then I put it over here, and then I update it, and then you can see here it will give you a diagram, visual diagram that can tell you exactly which state you are on, which event attached to which state, what event what state will transit from the original state with any event it trigger. So let's say if I click on inactive, I click on toggle, it go to active, and then click on toggle again, it go to inactive. And this it tell you what the side effect you have, and all of this it go, and then you can actually modify here, and it will show you immediately what the change. And this way, because you can use how you can visualize how the code flow is, you can actually limit down on the possible bug, because the bug is so very, it will be visible. Well, very rare. There's of course there's complex bug that you want to see it immediately, but a very simple bug or some bug that is very very awkward will appear there. And this way you can actually make it the code more reusable, because you can put on the logic in one machine and share between components. And the coverage for testing is much easier, because now you exactly know what to test. Like you want to test a state, you only write the test for that state, or transition for another state. You don't have to think so much about all the various features you put in. The tests are very concise and very in high quality. It's easy to debug and spot bugs, like I said before. And like you also saw, the component become very narrow into the scale, into only the basic logic, and whatever the logic was the same, it will be unite, and so it's easy to scale and easy to maintain. And finally, it's better code design and planning, because now we are modeling our code. We're not going to develop and just continue to expand the component. Whenever we get the features, we actually plan ahead what machine we're going to use, and modeling our component, our machine, our states, or our UI flow accordingly. And lastly, if you're really into, you found it interesting, there's a lot of resource about XState and state charts, state machines that you are very useful, very helpful to learn and to start with. First, you saw the visualize of XDay. The XDay have a great community that very helpful, and David Piano is the creator of XDay, very helpful on Twitter. You can also, if you have time, you can also read about how state charts and state machine concept were created in the book of the words of state charts, or you can also create UI from state charts. And if you're into Vue, then state machines will fill with XDay. Very nice articles were written. And before, it's totally recommended for everyone to check it out. And before we finish, my name is Maya again, and I'm a senior front-end developer of Cloudinary. I'm also a co-maintainer of Storefront UI and a nuxt.js ambassador. And I love to write, to speak, to share anything interesting I found about front-end, about web, about frameworks, anything that's helpful for other developers and helpful for me. You can always find me at mayashavin.com or Twitter or GitHub at mayashavin. So thank you and hope you enjoy my talk.